Alright, hey everyone, and welcome to our next lesson. This is all about surface area. So what I'd like for you to do is stop and think about this orange. What would represent a hemisphere of this orange? What would represent the volume of the orange? And what would represent the surface area? So think of the parts of an orange, like the seeds, the peel, the pulp, the actual stuff. Like, what does this represent? So a hemisphere of the orange would be if I cut the orange in half, then the half that I have in my hand is a hemisphere. The volume of the orange would be all the nice, good, juicy insides, i.e. the pulp. So you know how when you buy orange juice, there's no pulp or low pulp or whatever they call it, normal, original, okay? That would be all the meaty goodness that's inside the orange. And then the surface area should be the orange peel on the outside that you peel off to get to the pulp. Now, the formula for the surface area of a sphere is 4 pi r squared. That will be a formula that will be given to you, so there's no need to memorize it. We just need to know how to accurately select the formula and then plug in what we know to solve. So we need to find the area of the surface area of the sphere given. It says a radius of 11. So all you have to do is plug in 11 for your radius. That was a bad looking pi there. 4 pi. 11 squared. So then I type this in my calculator. I get 484 pi inches squared. The directions were not given as far as leave in terms of pi or round to the nearest decimal, so we'll just leave it in terms of pi because that's the most accurate answer. Alright, find the surface area of a sphere given the circumference. Okay, so this is the great circle circumference of 8 pi. So I need to take this 8 pi and set it equal to 2 pi r, I almost wrote pi times diameter, to solve for the radius. Then once I have the radius, I can plug it into the formula for surface area, which is 4 pi r squared. So I would need to divide both sides by 2 pi. I'm left with r equals 8 pi over 2 pi, and my calculator is 4. So I would take 4 and plug it in here for the radius, 4 pi times 4 squared. That's the surface area, so I get 64 pi feet squared. Pi is kind of off here by itself. 64 pi. There we go. Alright, now what if we want to work backwards? What if I want to find the radius if I know that the surface area of a sphere is 1,472 square centimeters? Recall, this is the formula for the surface area. I am looking for radius, and I've been given this number, which is the surface area. So I'm going to replace S with 1,472. To get R by itself, the first step would be to divide both sides by 4 pi. So in your calculator, do 1,472 divided by 4 pi, please. Alright, so did you get 117.1? And now there's a square on the r, so let's square root both sides, because remember, the opposite of squaring something is square rooting it. So the square root of 117.1 gives me 10.8 centimeters for my radius. Okay, recall that the formula for the volume of a circle is 4/3 pi r cubed. In the problem that we've been given here, the volume of the sphere is given, and I want to find the surface area. So it's my job to use the given formula for volume and solve for the radius in order to plug it in the formula for surface area 4 pi r squared. So the volume is 4,849.05. Now I need to solve for r, so I would divide both sides by 4/3 pi. And I'm left with r cubed equals, and type this in my calculator, 1,157.6. Now, to get the r cubed off, recall from the previous video that anytime I wanted to get the cube raising, okay, let me start over on that. Here's r raised to the third power. In the previous slide, we had r raised to the second power, and we did a square root. If r is being raised to the third power, we are going to need to do the third root, or the cubed root, okay, of both sides. Now, recall that to get the cubed root, you would have to, see the button that looks like this little arrow on your calculator? And right above it in green, you'll see this symbol. Because it's in green, it means we have to use the second button. So we're going to hit 3, then the second button, and then this button. And what should appear on your calculator is this little symbol with the 3 inside the square root. So the cubed root of 1,157.6 gives me a radius of 10.5 meters. Alright, I'm going to erase this. Alright, so we're going to take this radius and now plug it in. 4 pi 10 times, or 10.5 squared, which would be 441 pi meters squared. Directions say round to the nearest tenth, so it's approximately 1,385.4 meters squared. And that's my answer because it says round to the nearest tenth. Alright, so as you can see here, our next topic is to talk about the surface area of a cylinder. However, before I just show you the formula, I'd like to talk about it. What I have created here is a 3-dimensional cylinder in my hand. And what I want to do is I want to show you what this would look like if I flattened it out. So imagine that this is like a little can. Okay, you see it? Okay, if I were to take this apart, okay, the top part would be a circle. The bottom part is a circle as well. And then when I take away this outside piece, I get the length. Okay, I get a rectangular shape. This rectangle shape, the length of the rectangle is actually the circumference of the circle. And the width of the rectangle, is going to be the height given in the problem. Okay, so if we were to take a look at the formula, you'll see that the first part is 2 pi r squared. That's because you have 2 circles with an area of pi r squared. Now, you also have a rectangle, and the rectangle's length is the circumference, which is 2 pi r. And the width of it is going to be h, or height of the cylinder. Now, what's cool about this is that the formula will be given to you on the formula sheet. So it's not required to memorize it. I just wanted you guys to have an understanding of where the formula comes from. Not just, oh, another formula that we have to know how to plug in. I want you to understand why it actually exists and why we use it and how we came up with it. So let's go ahead and find the surface area of this cylinder using the formula, and we're going to leave it in terms of pi. Recall that the formula for the surface area was 2 pi r squared plus 2 pi r h. Okay, so 2 pi r squared are the area of the 2 circles. So 2 pi times 5 squared. And then the circumference is 2 times pi times 5 times a height of 10. So I can actually take all of this and plug it into my calculator exactly the way I see it. And I get 150 pi centimeters squared. It's kind of hard to draw pi on this thing. It ends up looking more like a box, but you get the idea. Alright, so here we have a cylinder with a radius of 3 and a height of 9. Why don't you take a minute, pause, and try to work this problem. And I'll go ahead and write the formula for you. Alright, so if you haven't paused to try the problem, go ahead and pause and try the problem now. Alright, so hopefully you have worked the problem and now you are unpausing the video to watch. I plugged 3 everywhere there's an R and a 9 everywhere there's an H, and I get 72 pi inches squared. As a reminder, anything that's area, regular area, surface area, is only going to be squared. In volume is when you'll start to see units cubed. Alright, here is another cylinder. This time I want you to round your answer to the nearest tenth. I've been given a radius of 5.4 and a height of 19. Well, I'm running out of room over here. There we go. Alright, so plugging in 5.4 for the radius and 19 for the height, I get 8,200, or no, not 8,000, woo, 827.9 inches squared. Sorry guys, shouldn't do videos when I'm tired, huh? Alright, the next thing that we're going to talk about is the surface area of a rectangular prism. What's really cool is that a rectangular prism has 6 sides. Each one of a different shape. So if we take a look here at this first, this is length times height, and the one in the back is also length times height. That's why we have 2 of those. Okay, these on the sides are h times w. Okay, that's why we have 2wh. And then on the top and the bottom, okay, we have length times width. So that's why we have 2 length times width. So this would be like if I was wrapping a box and I wanted to know the least amount of paper needed for wrapping the box. I want to know, do I have enough wrapping paper? Okay, so I would need to find the surface area in order to figure out how much wrapping paper I would need. So let's do an example, okay? All we have to do, I'll rewrite the formula here, that way you don't have to flip back, is to plug in length and width and height. Okay, so this is our length, this is our width, this is our height. So 2 times 5 times 8, oops, plus 2 times 8 times 4, oops, I'm getting a little ahead of myself, plus 2 times length times height. Alright, and I get 184 centimeters squared. No need to round to the nearest tenth, even though the problem says so, because it is 184, period. There's no decimal, there's nothing following it. It is our whole number, 184. Alright, so take a minute and try to find the surface area of this rectangular prism. I'll go ahead and write the formula for you, but then after that I want you to pause and try to do the problem yourself. Make sure that you are understanding this problem. Alright, hopefully you are just now restarting the video and you have already completed the problem and you just want to check, hey, did I do this right? Alright. So I labeled this as length, width, and height. If you labeled them something else, you're still going to get the same answer of 148 inches squared. Okay, just make sure that each one has its own, because 6 times 5 and 5 times 6 are the same thing. You still end up getting 30. Okay? Alright, well that's it for surface area. And we'll be preparing for our first test on Unit 3, and I will see you guys later.